So, to those who did not do well on the first time, that's fine. But you have to reconsider your learning behavior. Okay, you have to. You gotta go to the math center, you gotta get together. I know what you're gonna do. You gotta spend more time. Okay? Go to class more often. You have to reconsider your learning behavior so that on the next test you get better. And the third test you get better, then everything I just ignore. If you get better on the third time, then fine, of course. And again, I already told you gotta go show me something so that you can get something from me. Okay, as long as you get better. I don't know how much better, as long as you get better. Because I need to see how improved you are. Okay? And those who do well on the first test, congratulations. Okay? I see. You have to change. Change so that you get better each day. So that it shows me something and you deserve something in this course. Okay? We all grow up. So you need to show me something. To those who got a good grade, congratulations. Keep that up. Okay? I just feel that some students did not do the sample test. That's why. I designed the sample test beautifully, but nobody cares. You guys have to do the sample test. That's all. You can see that the sample test and the real test is not much different. And those students who got a good grade on the first test, I know that they did the sample test. Okay, so the second test, you have to do the sample test. Okay, you have to look at the lecture note, go through the example, do the lecture note, do the example in the lecture note, do the sample test. That's all. Then you will be all right. Okay, if you don't do anything, then of course the grade will be bad. Of course. Okay, but again, other than just the grade, My final grades will be based on so your learning behavior. You go to class often, yes. Maybe I'm kind of lenient. Some students did not even go to class. See the first day. I know some of you. And they didn't show up. Didn't do anything. No homework done, no nothing, no assignment done. Not even one. So that kind of student is, I don't know how I'm going to help. Okay, it's very hard for me to be lenient on those. Okay. So yeah, I think that's all. So try to get better each day. Okay. Valencia has many resources you can use. I know some of you have to work full time. It's understandable, but you have to understand this. Learning is a part of life. Okay? You sacrifice something for another thing. You have to consider which one is more weighted than the other. Okay. To some who didn't have to do full time, you don't have full-time job, please go to the math center. Assignment number 2, a lot of students improved this time. Yes, I feel it, and I take credit for that. Yes. Okay, but I want you to keep doing like that. Keep that up on assignment number 3. If you don't do well on assignment number 2 and number 3, then you have to get together. 2 students who did really well. I'm going to add the extra credit next time. Okay? Let me see. You have more. Any question?
100%.
And some of you, I asked one thing on the test and you guys show me another thing. It doesn't work that way. I asked you to do completing the square, you have to do completing the square. And if you show me this factoring or anything, then you won't get credit for it, of course. Okay? And you guys have to be organized. Don't scribble. You put something here, something there, everywhere. No order. You guys have to be ordered, right? Be organized. And not just in this course. You train yourself to be organized for the future, for your whole life. Okay? Write carefully. A lot of students skip step. You guys are not sure what you guys do, but you guys do skip step. So I don't know how. What's your name? Jacob. Let's see. Yeah, go ahead and go through, take a look at your test one more time. Let me know if you guys have any question. I already posted the solution, or not yet, but I will. I will post the solution tonight on Canvas, or maybe email. Go ahead and check your Canvas message. I will send the solution in PDF form so that you can go through. Did you do the test, Jacob?
Yeah.
There must be somebody here who saw it. Okay.
Thank you.
All right, one more time. Please reconsider your learning behavior. well, you have to consider that. Okay? If you don't do well, keep that up. Okay? Then you should be alright. This class is not really hard as long as you show me something. I try to be lenient on the next two, but again, in order to get something for me, you must be born. Okay? Alright, that's it, guys. Solution will be positive. If you guys have any questions regarding the test, talk to me at the end of the class. We have to continue. So assignment number 3, the next assignment will be due on Monday, right? Mm-hmm. And I will review the assignment number 4 on Monday. Also, if you guys want it today, I have it available already. You can come see me and ask for the assignment. But if you have not finished the assignment number 3, you go ahead and finish that. Get together. There's some good students in this course, for example, Leavis, for example, Sama. Yeah, get together, come and see them, and ask questions if you guys don't understand anything. Email me if you guys don't get anything. Yep. You get better each day. Let's see. Okay, so last time we stopped at some basic function, and we talked about the domain and range of those functions. We learned how to graph. It's a very traditional way of graphing. We just set up the table and plug in a point and connect all the points together to get the graph. There's one more question before we jump into the new concept. So the question I want to talk about today is, so this is continue. The question I want to talk about is the absolute function. Topic. So this is one of the functions I want to investigate. So absolute function has the form f of x equals to absolute of x. And you know the absolute of x, and then every time you take the absolute value, it's always positive. It turns out to be positive all the time. That's why the graph of absolute function must be above the x-axis. So if you graph the absolute function and there's a part under the x-axis, there will be something wrong. Okay? So let's draw the table. Okay? And coordinate system. Okay, so I want to plug in some value. Okay, so the easiest one will be 0. 0 give you what? If you plug 0 into the function, 0. Give you 0. If I plug in 1, give you 1. How about negative 1? 1. 2. 2. Okay, negative 2 give you 2. Also 2. So I have 5 points, and we'll have locate those points on the coordinate system. You will see that the absolute function graph has the V shape. That's a V shape. And last time I also said that every time we want to find a domain of a function, we look at the x-axis when we start scaling from left to right, not right to left, okay, from left to right. And we see that any point on the x-axis can we define another output, a unique output or not. So let's pick a point on the x-axis on the left-hand side, and I see that if I pick a value here, I have the output, a unique output. Okay, I have a point on the graph. Okay, and just imagine if you pick like all the point, any point on this side of the axis, you always have a point on the graph. You see? So you're going to have some point over here also. You pick a point all the way down over here. So you're going to have a point here. So any point. On the same thing over here. On the right hand side, if you pick a point on the x-axis, you can define another point on the graph. So we can keep doing like that. Our domain will be what? What do you think? Negative infinity to
Positive.
because it's defined everywhere on the x-axis. Okay. How about the range?
Bracket 0.
Bracket 0 to
Positive infinity.
positive infinity, because you see there's nothing under here. I told you it's always positive. There's nothing here. So everything from here up, right? So this we count it from 0. So everywhere, every point on the positive y-axis. Okay. So we have 0 to positive infinity as the range. Okay. Can we talk about parallel and perpendicular last time already?
Yes.
Okay, good. So you say that one of the way of graphing function is to set up the table, especially for a linear function. I remember I gave you one of the questions on the test, and I asked you to find x-intercept point and y-intercept point. Not a lot of people can do that one. I don't know why. You just need to define 2 points. Actually, you know how to get the value x and y, but you did not write it in a coordinate pair. So it's not considered as a point, and you lose some credit for that. Okay? So one of the way of graphing linear function is using the rise over run method also. And that method is when you graph, like, for example, like the table here. You just use the table to graph the basic one. Basic function. If you have like more complicated function, of course we're not going to use the table value anymore. No. We're not going to use rise over run method, because rise over run method is just for a linear function. We're not going to use x and y intercept point either, because that is also for linear function. So we have another method. Okay, we have another method. The method I'm talking about today is called transformation. And we also touched a little bit about transformation last time also, right? Have we touched transformation last time?
No.
No, right? No. Okay. So this concept basically is you transform the basic function to another function that's more complicated. Okay? The reason that we want to do that because of course we want to investigate the domain of that function. We want to see that function has certain property. So after we learn the transformation concept, we're going to talk about more property of function. And there are a few ways of transform a function. The first way I call it vertical shifting. Vertical shifting. Let's take a look at one of basic. Let's take a look at this one. How about this one? How about the absolute function? Okay. So I have a V shape here. So y is x. And I know that this function is absolute function. The basic one, or sometimes we call it parents function of absolute function. And now for the new function, I will be graphed based on this one. Okay? And I want to move this one up or down a certain unit. For example, I want to move this function up 2 units. So my new function, my new graph will be something like this. Okay, that will be my new graph. So the function over here will be f of x equal to absolute of x, but we add 2 to that. Because we move up 2 units. Or we want to move down. Let's see if we can move down enough. I want to move down 2 units also.
We can.
Yeah, you can.
Yeah.
It's b minus 2.
Oh,
Really?
F of
yes.
x.
Yes.
F of x absolute value minus 2.
So my new function will be f of x equal absolute of x minus 2. So you see that we can get a new function based on the parent's function by moving up or moving down a certain unit. Then we have the general math formula for this. The new function I call the f prime of x. This means prime. Okay?
Just a little comma.
Là kind of common sao. F prime of x equal to the O1 f of x plus k or minus k. So this is the new one. And this is the, let's say just the old one. The basic one.
Is it always going to be plus or minus? Or
Plus or minus. But usually it's plus, but I want to write minus also so that I know that it could be, we could
okay, good.
so that you guys know that it's moving up or moving down, subtract or add. Okay? And if k turn out to be positive, if k is positive, then we know that it's moving up. If k is negative, then we know it's moving down. You see, in this case, in our example here, my case 2, positive 2. That's why we're moving up 2 units. And we subtract by 2 over here. That's why we move down 2 units. Okay? Well, how many units you want to move? It's up to you. You can move like 3, 4, 5 units. If the question asks you to do so. Okay. Another way of transforming a function is horizontal circuit. We want to know if we can move it to the right or to the left by maybe adding a number or subtracting a number also, maybe. Let's see. All right. Let's take a look at this function. I want to take a look at a basic function, a square function. Last time we talked about that already, the square function. F of x equal to x squared. If you guys missed the class, please watch the video, okay? That's the best offer I give you. I mean, I don't have to do that. You guys know it. I don't have to do that, but I mean, I make a video so that you have a change if you miss the class, because I know that some of you have to work. It's understandable. Okay, you guys have to work, and you guys miss the class, that's fine. Maybe you have a family issue, you miss the class, but please go back and watch the video. And I want to move this curve to the right 2 units, so everything moves. So my new function, my new graph, will be something like this. Okay? So instead of adding 2 to the function to move up, we don't add anymore. For this one, the graph will be, the function will be f of x equal to x minus 2 squared. So you subtract by 2 inside the x, not outside. You see that for this one, we subtract by 2 outside. 2 is not a part of the function, but for this one, 2 is a part of the inside of the function right here. It's a part of the input. Okay. Yeah.
So, oh, sorry.
Go ahead.
plus 2?
Here we can do plus. If we do plus, then we'll be moving to the left. We move plus. If we do plus, the function will be like this. It's going to move to the left 2 units. So this will be x plus 2 squared. Okay, so you see that you can see the difference between this and that. This one, we add 2 to the function, to the original function. It's moving up. We subtract from original function, it's moved down. But for this, when you subtract by the x squared, but this is inside the x, okay, not outside, this is outside. It's moving to the right, and when we add 2 to the x, it's moving to the left side.
Why does negative move to the right though?
Why negative to move it to the right? Because just think about it. If you pick a number over here,
2.
it's not. For example, if you want to pick 2, right? 2 minus 2 is 0. So that coordinate move already. Instead of 0, it's moved to 2, 0. The coordinate of this point over here is 2, 0. So you say if I plug x equal 2, 2 minus 2 is 0, 0 squared 0, so the coordinate will be what? 2, 0. Okay, it's not negative 2, 0 anymore. Okay, it's not it. So that's the only difference between vertical shifting and horizontal shifting. So based on this, I have the general formula. The new function f prime of x will be equal to the O1
X
plus and minus k inside. Inside, okay? It's a part of the argument. It's a part of the argument. This is not, number 2 here, the value k over here, is not a part of the argument. Okay? So this is the new one, this is the O1 f of x. Okay. So if k is positive, so we know that we will be moving left. And if k is negative, we move it to the right. Okay, so it's the other way around. If we compare this to the vertical shifting. Everything's clear. Let me see, I can give you an example so that you can practice yourself. See, I have something over here now. See. Okay, how about this one?
Is that formula that's supposed to be squared?
Oh, that's a general one. So I mean,
Oh, okay.
yeah. So the graph I give you is just a typical example.
Okay.
Yeah, the formula is a general one. How about this? Or maybe we should do a couple more. Okay, let's do this. I want you to get together. Okay, let's get together in a group of 3 or 4, and I want you to sketch this. So go ahead and get together. We have more transformation, but let's do a couple of examples with these 2. Okay, so I have f of x equal to x square root of x minus 2 plus 3. Alright, so go ahead, turn around. Please, can you get together with the group over there? And can you go ahead, turn around and talk to each other? Go ahead, discuss how we can graph this, then I'll go through that. Okay, let's take we have a lot of time, so let's take about maybe 5 or 10 minutes.
Are we together?
Okay. So we're going to use the transformation we already learned here, vertical shifting and horizontal shifting, and we use the basic function we already learned last time with this radical of x. Okay, go ahead, talk to each other for a few minutes. And I'm gonna go through the solution.
Put it in a graph?
So when you graph it, you have to graph the basic one first. Anyone realize the basic function over here? You have to graph the basic function. Yes. Yes. What is that called function? What's that? What's that called?
Square root.
The square root function. Yes. Square root. The basic function here is the square root function. Okay. The radical function I mentioned last time. So you're gonna grab the radical function, then you're gonna transform. You're gonna shift up or down, left or right, depends on the question I have
So
here.
apparently this is the basic function and we have to do this. So we have to do both.
So the basic function now is this function.
You can't have 0, you can have 2.
So this is the basic function. There you go.
Yeah,
That
you
is
can
the
have
basic.
2.
So go ahead, graph this one first, okay?
Because if it's 0, then it's negative 2, we can have negative inside of it. So 3.
Talk to each other, guys. You guys have to learn from each other.
I'm gonna do 6.
Yeah, change the battery. The test.
Yeah, we can have negative. I think that's
Yeah.
Okay, so after you graph the basic function, you will do the transformation, okay? We'll do transformation.
Go to the right too, and then since it's plus 3 on the outside, it's gonna go up 3.
Can you guys turn around?
Do that.
So you made 2 of them.
This one is the initial function, and then this one is the new function based
How
on.
about you guys? You cut that last time, right? Did you cut it last? There you go. So,
That, like I said, it's the
so
basic
he
one.
has the basic
I'm not
function.
saying that it's like the actual what it's supposed to look like.
Makes more sense.
Okay, so after you graph the basic function, this is square root of x. You have to do the transformation. Okay, you want to know how many is moved left, how many is moved down, how many unit is moved up,
Okay, so
how many units is moving to the right, how many units is
so we
moving
have
to the left.
3 up.
Yeah.
Yeah.
So it's moving 2 to the right and 2 and 3 up.
So this.
Well, that's just the initial start point is that.
Just whatever it gives you after that.
Yeah, whatever
This
gives
is
you,
just
yeah, this is just, I think he just wants like the initial start point and then whatever goes on from that.
That's the base. The negative 2 does something.
Yeah.
The negative 2, I think it needs to go down. So
So for this one, yeah, all right, good. It's kind of like that, right? Kind of like that.
Minus 2.
So after you do this, how about do this one? So that's the one example. Let's do the next one. If you finish the first one already.
Oh, no, I'll never do that.
That's what happened to me. I was like, what's going on here?
wait, let me see.
There you go. How about this one, guys? Go ahead, define the basic function first.
My goodness.
So it's already
This is probably tricky question.
No, I was but send over the shot today.
No, you don't have to, as long as you can, the transformation, that's fine. You don't have to be exactly, because we're doing sketching. We're not graphing. That's the question, it's sketching. Okay, so after you finish this already, go ahead, try to find the basic function for this one.
The basic function.
Control over X, right?
Is that
I think.
Yeah.
And then there is horizontal and
Yeah, the horizontal and vertical shift, yeah. I don't know.
I don't want to be guessing though.
Alright, let me go through
I think it's
the
one.
solution for this one.
Wait, can you use the base?
Okay, so what does it mean by add 3 over here?
Oh, did I do it wrong?
Goes up 3.
Go up 3, how about over here?
Goes right through.
Go right to that's all. So I start from the basic function, which is look like this, right?
Calculate.
Radical of x. Now I'm gonna move up 3 and move it to the right 2. So 1, 2, 3. Move it to right 2, 1, 2. So my function will be like this. All right. That's
Oh, no, I
all.
did it right.
Yeah.
No, I
Okay.
didn't.
Everybody got it?
No,
Go ahead, try to do the example two.
wrong.
Oh, wait, real
Should be
quick,
like
what's the base for
this.
this?
Yeah.
Is it 1 over x?
Yeah.
Oh
The
yes.
second one.
Okay.
We got
The basic of this one, it will be 1 over x. Okay.
So the
1 over x. Very good. Very good.
It's a line or something.
Yeah, that's it on the line, so, yeah, that's about it.
we have 0, we have -1.
So on the test, you have to state how many it move up, how many it move to the right. Okay? Because we do example here, you don't have to. But on the test, because I ask you state the transformation, you have to say the function moving to the right, moving to the right 2 unit and moving up 3 unit. You have to say like that on the test. Okay? Go ahead and try the example number 2.
Yeah.
It's the one that's right.
So, yeah, okay. Okay. I think I got this one.
Okay, everybody knows the graph of the 1 over x, right? So all those graphs you guys have to memorize, okay? Because just think about it, you guys don't memorize, then how you guys graph the transformation if I give you something on the test.
It's basically going down.
So the initial one kind of looks like this.
No.
So then we know
The
we're going to
universe
shift
implodes.
down to.
That's
kind of hard to graph.
And again, this is
Two, basically.
this is sketching. You guys don't have to be perfect, okay?
Maybe?
You
Right?
guys don't have
It
to be
should go
perfect.
down 2 and to the left 3. That's what it should do from the initial. I just don't know where to start that.
Oh, it's like this,
Yeah.
So it
Yeah.
comes down to.
right?
And to
Do you wanna?
Yeah.
Let me try one more number.
Yeah.
I'm gonna do
I just don't know what the.
That's probably the best.
I think,
I'm not
well,
testing your
half, it's
I think you guys
What is it?
That's for.
right?
What's
For 1 over x.
1 over
So
x.
it'd be more than-
Yeah.
That's what it is.
4
Half.
minus 2.
So this is.
Yeah.
I gave you guys 1 over x last time, right?
Yep.
So that one.
Did I?
I think so.
No?
No.
Oh, so I didn't give you 1 over x last time. I'm sorry, guys.
Minus
So
2.
we missed 1
Okay, so
over
that's
x
what I
last
thought,
time.
because
Okay,
the
so this is
original
1 over x,
And
guys.
one over here and one over here, that's where you go, right?
Yeah.
So basically you just got 2, 1 and 2.
No, 1 over x looks like this.
Yeah.
No
That
way.
Maybe
There you go.
also top of X.
At least.
It's rational function. I forgot. I didn't know what
Right
it was.
here.
I thought I already gave you guys rational function.
Yeah, it would like that.
Yeah, and then it goes.
Yeah.
That's why, it's because it's not touching the line of the original, just because you don't get to see everything as the
So I
original.
have to do the odd.
Yeah.
So it looks pretty cool.
You got odd already for the radical?
So something different with different color,
And minus 2.
more like this.
2.
But what you already had it.
Oh, this is cubic. I'm talking about the
So that's the
radical.
original.
Oh, you do?
Yeah.
It's round to the line.
Yeah.
So
I mean,
now
how come you?
you go-
No, it's just the graph of the even.
Like if you had a d across.
Not just another part. It's not
Yeah.
like another part.
I
So we're gonna go with that. Alright, so this is the graph of the rational function 1 over x. So this is considered as one of the basic functions also, okay? So I forgot to give you last time, actually. We don't have time last time. So I thought I already covered that. So this is rational function, okay? And anyone can tell me what is the domain of this?
Negative.
Negative infinity 0.
Negative infinity to 0.
Yeah.
0.
0 to.
Positive infinity.
Uh-huh. How about the range?
Negative infinity to infinity.
Negative infinity to
0.
0 again because you look at the x and y.
Yeah.
Derivative is 0, union with 0
Zero.
infinity. So that is one of the basic functions, okay? Rational function we call rational function. So right now, we want to move, what does it mean by -2 here?
Down 2,
Down 2. And how about 3 over here?
left 2.
Left 3.
Left 3. Okay, so we're gonna move down. We're gonna move down 2 units. Okay? Look at that. So this is the x-axis. We move down 2 units. So 1, 2. So my new x-axis will be this. Okay, that is my new x-axis. And we move it to the right.
I think it's right now.
Move it to the left 3 units. So my vertical axis, my y-axis, my new one will be over here. There you go. So my new function
Yeah.
will be this.
We was woordkaart, was it?
Will be something like this.
Okay, that makes it a lot easier to graph.
Yes.
But it's down to?
Yes, it's moved down 2 units. So the x-axis go down 2 units. So I draw the new x-axis.
Told you I got it right.
Okay. And the vertical axis, I move it to the left 3 units. So I have a new y-axis. Okay. And actually, this axis here, we call it vertical and horizontal asymptote. So this is, we call it horizontal asymptote. Okay. We call it horizontal asymptote. Yes.
So you move down instead of up?
Yeah.
Sorry, I was catching up.
Up, yeah, it's minus.
Oh, alright,
It's minus here. We move down.
so I was thinking like this.
Yeah. Because the reason over here, we want to move it to the left because 3 is a part of the argument. It's inside function. Okay? So this is horizontal asymptote. And the vertical one, we call the vertical asymptote. Okay? Or vertical asymptote. So every time you see the asymptote, every time you define the asymptote, you know when you graph, you cannot cross the asymptote. You see that over here? When I make a curve, I get close.
I don't know
how to spell it.
You get close to the asymptote, but I never cross that. So if you grab and you cross it like this, it will be wrong, okay? So I might take some point off over here. So it never crossed the asymptote, okay? And over here, it get close to the horizontal asymptote,
Oh, so it's close. It just never touches.
but it never touched it. Exactly. It's very close, but it's never touched it. Right. It's good now? Any other question? Good? Alright. So last time, I'm sorry guys, last time we don't have enough time to talk about rational function. And maybe before we continue with the transformation, I don't know, I just took a look at the lecture note and I see that we're still missing some basic function. I thought I already gave you guys everything.
It shouldn't touch it.
Okay. Or maybe we just continue with our transformation, then I give you more basic function later. Okay? So right now you know rational function, basic one. You know square function. You know absolute function. Last time I gave you the cubic function already. I gave you the what are the radical function if n is even. N is even, this is one of the cases for radical. It's an invisible number 2 right here. It's even. But I have give you the case when n is odd. Okay? So if the index over here is 3, 5, 7, 9, 11, then it doesn't look like this anymore. And we will talk about that later. Okay? So everybody clear on transformation so far? Okay? Horizontal and shifted. Yes?
Are we ever going to have something that does not start at the origin?
That's the origin. Well, most of the basic functions they start with the origin.
But like on the test or anything, like on the
on the test, I'm gonna give you something like this. Yeah. No. Well, there's some function, because right now we're learning a basic function, so I think that there's some function that's we started something somewhere else. Of course, we have some function like that, but for this course we don't have to. Okay, so that's everybody good with vertical shifting and horizontal shifting. Another transformation we want to talk about is reflection. Okay, and the first kind of reflection is reflection over x-axis. Okay, it's a reflection about the x-axis. All right. Example. Okay, how about I have this kind of function? Oof, it's not really good. So that's not nice. Okay, so I have this cube root function. So it's not just the cube root, it's the fifth root. So if n is odd, over here is n.
So it's the fifth root?
Third root.
Okay.
Sorry. If n is odd, it's always look like this. So including the fifth root, yes. So this is third root. So n is odd, n could be 3, 5, 7. 9, 11, and so on. So if we check the domain of this function, what would be the domain?
Negative infinity, positive.
Okay, negative infinity to positive infinity. Everybody agree with that?
Yes.
How about the range?
Negative infinity, positive.
Same thing. Okay. Now I want to reflect this graph over the x-axis. So basically I just want to mirror it over the x-axis. So my new graph will be something like this, right? You see that the branch over here, I reflect it over the x-axis. I'm going to have something like this. And the branch over here, if I reflect over the x-axis, I'm going to have something like that. So my new function will be f of x equal to negative cube root of x. Okay, the original is f of x equal to cube root of x. Right? So if I reflect it over the x-axis, my new function is negative of the original one. Okay. Yes.
Would it be alright if I put like a bracket around like the cube root of the x and the negative outside of it to show like it's distributing into it? Just so it's
No, we can't. Well, for the cube root, yes, we can distribute, but in this case, I want to leave it outside because I want to let you know that in order to have a reflection over the x-axis, we have a negative in the front. Okay. So the general formula for this will be f prime of x will be equal to negative f of x. Okay. There you go. We cover the odd radical. We have to go back a little. All right. Everybody clear? Okay. Another way of reflecting a function reflection over y-axis. Let's see any other function we have not covered. Let's consider this. Cubic, absolute, radical, we already covered. Cubic, we already covered also. Okay. One of the rational function here we already covered. Okay. How about I have a function like this? This is also another form of rational function. This is f of x equal to 1 over x squared. So this one is f of x equal to 1 over x. And this is f of x equal to 1 over x squared. This is one of the basic functions also. Okay? Alright, let's talk about the domain of this.
Bracket 0.
Domain is negative infinity, 0,
Zero.
union, negative,
Mhm.
or 0.
So negative infinity to 0. Do you think we include 0?
No.
No.
No, because it looks like it never crossed it, because asymptote, right? Yeah? Union with 0, infinity. How about range?
0, infinity.
Yeah, because we don't have anything down here, you see that? It's nothing down here. So we have 0, we include 0?
No.
No.
0.
Okay. Now, I want to reflect this graph over the y-axis. Okay. What are we going to do here? So, they have two branches here. So if I reflect one of the branches over the y-axis, for example, I want to reflect the left branch, or the right one, I'm sorry, I want to reflect this one over the y-axis, so it becomes like that, right? It becomes itself, right? And this is, if I reflect the left one over the y-axis, then it becomes the right one.
Oh, let's draw this nicely.
There you go,
Just make a thicker.
different color. Just different color. So my new function now, the green one is the new, will be f of x equal to 1 over negative x squared.
Let's use my pole.
Oh, it's negative x.
Yeah. But it's the inside.
Come on,
It's
Jake,
inside the
please.
argument. It's inside the argument. It's not outside. This is outside. If it is the negatives outside the function, then the reflection over the x-axis. If it's inside, it's the reflection over the y-axis. Okay? Okay. Then my general formula will be f prime of x equal to f of negative x. Okay. So I want you to memorize this graph, okay? The basic one, I want you to memorize the basic one for 1 over x squared. I want you to memorize the 1 over x, the absolute, the square, the cubic one last time. Okay. So there were 6 or 7 basic functions already. Because if you don't memorize the basic function, you cannot do transformation. Okay. All right. Let's see what else we have here. So that is the reflection. Any other questions?
So across
Yes.
the x-axis, it's on the outside of the x, and then on the y-axis, it's on the inside?
Yes. Yes. The negative will be inside. Okay. All right. Let's see. We're gonna have some more. Another kind of transformation. number 1, 2, 3, number 5, number 4. I'm going to erase this. The next transformation I want to talk about is called vertical stretching and compression. Vertical stretching and compressing. Okay. Let's see what basic function we're gonna use here. Okay, maybe I'm gonna use the square function for example, or maybe the absolute one. Let's see. Okay. 1x. So let's use the square function. So I have the square function that looks like this. Everybody know that already. This is fx equal to x squared. If I want to stretch this function vertically by a factor of 3, for example, then the new function it becomes steeper. So when I stretch this, the new function by the factor of 3, or by the factor that is greater than 1, the new function is become like this.
Skinny.
Yeah, skinnier. So my new function over here will be f of x equal to ax squared, with a is greater than 1. So the value of a, we call that stretching factor. So if it is greater than 1, it's skinnier. Okay? If it's between 0 and 1, it's like wider. That's why I say compressing. So the new function.
So it can never be negative.
Where's my other color? Oh, right here. Okay. There you go. So this new function will be f of x equal to ax squared also, but a between 0 and 1. So usually we call this compressing factor or stretching. This doesn't matter. It's just the name. Okay. So this is compressing factor.
So compressing is expanding kind of?
Yeah, it's kind of getting wider. It's getting wider. So this is I can use this is get wider, and this is like elongated. Okay. Everybody clear? So my general formula will be f prime of x equal to a f of x. With a, it could be greater than 1 or between 0 and 1. Okay. Greater than 1 is becomes skinnier. It's between 0 and 1 it is
But it can never be 0.
what's that? It cannot be 0. Okay. Any question? Okay. Last one. Last transformation. Number 5. Let's see, there's one we call. What's the name for that? Okay. I call it horizontal shrinking. Shrinking, yeah, shrink.
I thought you said stinking.
It's shrinking. Alright. Let's consider this function. How about we use the absolute function, okay? So we have absolute function, the basic function that looks like this. And I want to shrink that V-shape, okay, horizontally by a factor that greater than 1, for example. Okay. Okay, by the factors greater than 1. So my new function will be, let me think. My new function will be something like this. Okay. Yes. So over here, a is greater than 1. So my new function f of x equal to 1 over a absolute of x, with a greater than 1.
What's the difference between that and the vertical?
It's not much different, actually, to be honest. It's not much different. I mean, for this one, I mean, when you plug in the value, you keep the x component, and the y component just keep increasing. For this one, when you plug in the value, you keep the y component, and the x component is increasing. So it's not very much different, but when you see the function right in this form, you have to stand this horizontal shrinking. Okay? But the shape is kind of the same.
Yeah.
Yes.
And then it could never be kind of like widening like
It
that
can,
one?
yes. We're gonna talk about that too. So if it looks like this, okay, my new function will be f of x equal to let me see. I think I'm a little bit wrong here. I'm sorry. The a should be inside, guys. Okay, so the a is down here. This is ax here. And this is okay, so this is also inside. Only one will be a is x, and with a is between 0 and 1. This is a part of the argument.
It's not 1 over a, it's just a.
It is 1 over a, but when we factor, it's shrinking by the factor 1 over a, but when we write a function, we have to write a over x. So it's still, it is, so it's still shrinking by factor 1 over a. We're going to go through example. It's easier for you to understand because this is very general. Okay? Because when we sketch like this, it's very hard to see, you know. Okay?
I got it.
Again, over here, same thing. It's shrinking by factor 1 over a also. So this string horizontally, and the other one, so this is string horizontally. And this is, I can say, this is stretch horizontally. So if you compare horizontal shrinking and vertical stretching, I can say that stretching horizontally is compressing vertically.
Oh, so they're kind of like.
Yeah,
out.
it is. Yeah, it's kind of the same thing. Okay. Any question? Let's take a look at example. I think we should go through examples. It's much easier to understand with example. Okay. Let's see. All right, let's see if you can sketch this or not. Okay, so I want you to sketch f of x equal to 1 over 3 x cubed.
Do you want the initial graph? as
Yes,
well?
we have to use it. What is the initial graph? What is the parent's function over here?
Right, it's over
What's that?
Right. I mean,
X?
X
The
cubed.
cubic.
So
The cubic. We call it cubic function. So the parent's function is a cubic function. And what it look like? Okay, we have to memorize all of them, right? What it look like? Yes, it's gonna look like that. Okay, it's gonna be something like this. So this is f of x equal to x cubed. I believe it's you understand more. It's still one. All right. So which one we're gonna use? Horizontal shrinking or vertical stretching and compressing? Okay, vertical stretching and compression because the a values is in the front of the original function. So the a value over here is 1 over 3. So a in this case is 1 over 3. And a is between 0 and 1. Because 1 over 3 is between 0 and 1. So my new function will be compressed horizontally. How am I going to graph this compressed horizontally? We're going to sketch, not graph, sorry. So just imagine you just compress it vertically. So this will become the lace, right?
Yeah.
The compression gets wider now.
There you go.
Oh, it's the opposite of when you speak.
What's that?
It's the opposite of when you speak.
Oh,
Oh, no, I'm
we-
saying, like,
yeah.
I'm thinking about the mechanical part. You're gonna be compressing is you compress, but in math it's the opposite.
No, but this is compressing vertically.
I know, but
Yeah.
We're just seeing the. I'm just saying the other way.
You don't say, you always think the other way around?
Mechanically, that's how I think.
Oh. Well, it depends on the direction you want to compress, though. You can compress vertically or you want to compress horizontally, okay? So they become this. So when you compress vertically, it's the same as stretching horizontal. Kind of, the graph is kind of the same. So if you stretch horizontal, just imagine you stretch them out like that. It's kind of the same thing, okay? Everybody clear? Okay. Let's see, we have another example. Let's see. How about if we have a function that a is inside the argument? Let me see if we have it or not. Okay. Okay, how about this? Let's do the easy one. Okay. Erase this. Sketch f of x equal to f of 2x. Let's see. And I have the graph of f of 2x is this. Oh, I have the graph of f of x is this. So this is the graph of f of x. Okay, now we want to graph the new graph, which is f of 2x. And you see that the factor 2 over here is a part of the argument. Okay. So what we are doing? And a is greater than 1. A is greater than 1.
So it's gonna be shrinking inside?
Yeah, it's going to be like that, right?
Yeah.
Okay.
Okay. So it's going to be horizontal shrinking. So you're going to be something like this. Okay. But we need, because right now this is, we need to check like each value of the function. This one is not a typical function over here. It's not like this anymore. This is f of 2x. So we need to shrink horizontally one by one by the factor, by the one factor of 1 over 2. Okay. But we need to check one by one every point of this graph. Okay. Okay. So the problem is if I give you this, how do I know the coordinate? So let's see. Let's call the coordinate over here is -3 and 3. Okay. And the coordinate here will be how about the coordinate? It will be what? How about this one here? 1, 2, 3. So how about over here will be -1 and oh, we don't have time. -1 and -3. So go ahead and write them down. So next time we're gonna go through this, okay? We don't have time for this. Go ahead and write them down. Go ahead. Then next time I'm gonna have you guys grab this. All right, good job, guys. Yes.
Why did you read?
What's that?
Why did it read?
Oh, this is not absolute. It's not absolute. It's just any kind of function. What I said. Yeah, it's not this one.
I thought it was.
Yeah, that's why I didn't say f of x equal to absolute of x. Okay, it's another kind of function, but it's still a function. Yeah, it's still a function because it satisfies multiple lines.
Yeah. yeah, yeah, yeah.